I think I'll shoot section 5.1 and 2 videos because it could take a long time. So properties of exponents. What you should recall is that if I have x times x, I write that as x squared. If I have x times x times x, I write that as x cubed, or x to the third power. So what happens if I have x squared times x cubed? Well, it's all of these x's multiplied together, which becomes x to the fifth. So we have the property called a product, that's multiplication, of a power. Here's my two powers. So what do? I add the exponents. 2 plus 3 is 5. That should be relatively familiar. What happens if I raise a power to a power? So x to the second power raised to the third power means x squared times x squared times x squared. So what would that give me? 2 plus 2 plus 2 is 6. So the shortcut is x squared raised to the third. What do? I multiply the exponents, and I get x to the sixth. That's a power of a power. So the general rule is when I'm raising a power to a power, I multiply. When I'm multiplying powers, I add the exponents. All right. What if I have two different monomials being raised to a power? So this is a product. I'm multiplying this times this, and I'm raising each one to this power. So it's not distributing, but this cube belongs to the x, and this cube belongs to the y. So I have to do x to the 2 times 3, y to the 5 times 3. So I get x to the 6th, y to the 15th. X to the 6th, y to the 15th. I mean, really, this is x squared, y to the 5th, times x squared, y to the 5th, times x squared, y to the 5th, right? 3 times I'm multiplying this together. So what I have, x squared, x squared, x squared, that's 6 x's, y to the 5th, y to the 5th, that's 15 y's. But the general rule is power of a product, the n belongs to the x and the n belongs to the y. And proceed as you would with this rule here. What about this idea of a negative exponent? Here we go. You guys got to learn the difference between a negative exponent, and eventually we'll have fractions as exponents. A negative exponent really means change my place in the fraction. Everybody's a fraction. This is x over 1. And so really this is telling me I belong in the denominator. So x to the negative 2 means 1 over x squared. You have to memorize that. There's just no way around it. So x to the negative n equals 1 over x to the n. That's the rule for a negative exponent. Later we'll talk about, I like to emphasize that it means change my place in the fraction, because sometimes we'll have negative exponents in the denominator. That means they actually belong in the numerator. Anything to the 0 is, usual answer is 0. Anything to the 0 is 1. Another thing you have to memorize. There's no excuse for it, not knowing it. Memorize it. Now, why is this, Viv? Well, think about it. Suppose I had x to the 6th over x to the 6th. Well, that's just 1. And, down here, that's why we introduced this one later. So x to the 5th over x to the 3rd. Think about what that means. X times x times x times x times x over x times x times x. Well, what happens? This x over this x, we say cancels, but remember what's really happening is x divided by x is 1. X divided by x is 1. X divided by x is 1. And what am I left with? X squared in the numerator. So the rule for quotients is to subtract. As long as the base is the same, these both have to be x's or 7's or 2's or y's. You have to have the same base. Then you just subtract the exponents. So that's going to take me back up here to the 0 thing. X to the 6th over x to the 6th is just 1. And 6 minus 6 would be 0. So following this rule, that'd be x to the 6th minus 6th, which would be x to the 0, which now we recognize is just 1. So anything to the 0 is 1. Just like up here, when I'm multiplying, I add exponents. When I'm dividing, I subtract exponents. And then finally, what happens if I have a quotient raised to the power? Well, just like up here, the 3 belongs to the x and it belongs to the y. The 6 belongs to the x and it belongs to the y. So just raise the numerator to the 6th power, raise the denominator to the 6th power. And that's the power of a quotient. N belongs to the numerator, N belongs to the denominator. And then the other two things we're going to look at, actually, I'll just show you how to do those, have to do with scientific notation. So when I do the practice, I'll go through those. So that's the lesson about properties of exponents. I'm not going to worry too much about whether you recognize. So I think the worksheets say name the power that you used. I don't really care if you name the power that you used. I think it does help you remember them a little better if you're thinking about what you're doing. But know the rule. Know the rule. Know the rule. All right, there's the lesson, and in the next video, I will do a bunch of examples.